My name is Milt Hetrick. I'm a member of First Universalist Church in Denver, Colorado. I'm also a member of the Green First Task Force, which is part of the social justice initiative there at First Universalist. I want to provide a quick overview of a new energy system that was installed at our facility several years ago. Actually, it came online mid-year of 2018. And it's somewhat unique in that we attempted to do what we could to reduce our carbon emissions, carbon footprint, by adding solar to our roof and by replacing our natural gas furnaces with ground source or geothermal heat pumps. So I'd just like to go through that briefly and describe what was done. Try to share my screen here and bring up the first chart. And what we're showing here is a drone photo of the renovated facility, which shows the solar modules on the flat portion of the roof, and there's a few up here on the slanted portion we call the oculus. The system is rated at a 56 kilowatt rating, and it's accompanied, the energy system is accompanied by a new HVAC system that as I said, uses ground source thermal energy and some of the latest heat pumps. There are a total of 10 different heat pump furnaces throughout the facility. There are 3 in this round portion in the basement, and the rest of the 7 are in this flat portion in the basement. The sum of all the furnaces totals about 35-ton rating. So that's what the so-called ground loop heat exchanger, which was installed in the north parking lot, which is off to the right here. You can't see it in this photo, but there are 12 boreholes that were drilled in that vertically in that parking lot, and then black plastic pipe was put down, U-shaped pipe was put down into each of the boreholes to exchange thermal energy between the earth and the building. So what I'd like to do next is share one of the monitoring systems that we're using to look at the performance of the system. So what we have here, I'll try and enlarge this blue segment. We're just simply trying to depict that we're now a solar powered facility, meaning the sun comes in, shines on the solar photovoltaic system, generates all the electrical power that we need. And some of that power then during the day is actually pushed onto the grid and saved, but there is some used in the facility itself for lighting, various appliances, hot water heating. There are 5 energy recovery ventilators systems that bring fresh air into the building and do so by exchanging thermal energy with the outgoing air to conserve energy. We have 5 ERVs that are powered by solar electric, and we have the 10 geothermal heat pump furnaces. So what this graphic does is it lists the 5 ERVs, and on each unit, we capture the temperature of the air that's coming in, the fresh air, and the exhaust air that's going out, the return air that's coming in from the stale air, and the fresh air that's going into the building. And then we also show the 10 different heat pump furnaces. There's 3 that service the sanctuary area, 1 for the office area. There's another bank of 2 furnaces for what we call Friendship Hall, and 2 more mechanical rooms with 2 furnaces in for the rest of the building. And in this part of the graphic, what we are showing here, if I can expand this, is just to scale the building. There's the round portion of the building. And then out in the north parking lot, we have the ground loop with the boreholes that go down 400 feet and exchange energy with the earth, as I indicated. So those 12 boreholes are plumbed together into 3 different circuits. And what this depicts here is that each of the 3 circuits, the water comes in and we sample its temperature, comes in around 50 degrees. It's mixed into a common, about a 4 or 5 inch pipe that goes throughout the building then. And right now, since we're in the heating mode, we take that water that's at ground temperature, extract heat, and then return it. It's cooled to 46 degrees roughly, and put it back into the system, recirculate it in the ground, and add more energy. And this is a closed loop. There's the circulation is carried out using some a Velo pump. Actually, there are 2 pumps. It's a redundant system. Only one is operating at any one time. And there's a control unit that switches from one pump on one day to another pump the next day. And it just alternates so that the 2 pumps are getting equal runtime. But this avoids a single point failure, so that if one pump did fail, and our system would go down if we didn't have the backup. So the way we have it, if one pump goes down, we can isolate it, run off the redundant pump, fix the broken pump, so to speak, and continue with a HVAC system without stopping. So on each of the furnaces, we have 4 temperatures that we measure. 2 air and 2 water. So at this point, I see the office heat pump furnaces operating. It's putting out supply air is 85 degrees. The return air that's coming into it, the cooler air, is at 65. And the water temperature going in is at 54 degrees. And the water coming out after we've extracted energy from it is at 47 degrees roughly. So this is what, like an 8-degree temperature difference between the water temperatures, and 17-degree temperature, I guess, between in the air. So this is real time. We have this data available for us to review remotely. We just go to the URL up here. Anyone can see it. It's WEL server server.com/WEL1022. So this is the time that I'm recording it on the 15th. So it's refreshed every couple minutes, I believe. So this allows us visibility into what's going on with the system and the ground loop without having to go on site and actually measure the temperatures. What I'd like to do at this point is then share my screen and show what the second monitoring system is, which is referred to as the E-gauge system. And let's see here. If you go to this URL, let's see if I can find it, I guess. There we go. I'll have to provide that to you later, but you can see it's eGauge 41397 dot eGauge without the E dot ES slash 5F2E0 slash classic dot HTML. So anybody can see this as well. When it comes up, this is what you'll see. This depicts the solar production. Over on this side of the curve would be for yesterday. Here's midnight, and here's what we've been producing today, which is the March 15th. But I want to get rid of that information to show you something else. Down at the bottom, there's a table, and each of the 10 furnaces is identified here, as well as the ERVs and some other key appliances. What I'm going to do is activate the furnace that services the office area. It's referred to as heat pump number 4. And you can see it cycles on and off, on and off. However, during the day, when if the temperature outside is more than, say, 20 degrees from the set temperature that you're trying to achieve, this 2-ton rated furnace is undersized, and it just stays on until, well, eventually it catches up and then can recycle. So this is one issue that is still unresolved. We need to probably replace this with a 4-ton furnace because of this long on time. We have found that it heats up and can actually damage some wiring and things. But I also want to point out that at any time we can look at other furnaces. So here's heat pump number 2. We'll add in number 3 and number 1. These 3 furnaces service the main sanctuary part of our facility. So we can do this, as I said, for all the furnaces. Okay, I'd like to share one other graphic. This is a series of pictures taken in the main mechanical room where the geothermal pump is. So anyway, what we have at this side of the graphic shows 3 holes coming through the concrete foundation from the ground loop. And those 3 circuits are combined into one larger pipe. And we come along here, and here's an access port, I think, that would be of value to look at in more detail for servicing the system. There's the hydraulic separator, and then that pipe continues on through the facility and the 10 furnaces tee off of that main circulator. The flow comes back. In this case, the colder water comes back. And here's the pump, the Velo pump that we talked about, the 2 of them actually. And then back out into the 3 circuits that are buried in the ground. So that's the closed loop system. And it's in the mechanical room in the basement of the round building. So with that, I think I'll close